Hey guys, welcome back to my tutorial series on PyGui. In this video, we're going to be talking about the value storage system. Now this system is a little bit different than how other traditional GUI libraries handle values. In a normal system, when you go to create a widget, for instance, like a checkbox, okay, it has an internal value that it controls. So in this case, that could be, a bool. When they check the box, it changes this value, and that's it. And whenever you want to query the checkbox status, you would actually ask the widget itself, hey, is your value true or false? All right, that's how a typical UI system works. But that is not how PyGui works. All right, it works a little bit differently. Basically, we have this thing called the value storage system. And what this does is contains a key value pair that basically keeps up with the type of the value and what the value is. And whenever you actually ask, to get a value or to set a value, you're not interacting with the widget itself. You're actually interacting, like I said, with this system. All right, so it kind of acts as a little bit of a middleman. Now, the way values get logged here is when you create a checkbox and you give it its name, C1 for example, it checks the value storage system to see if that value exists, and if it doesn't, it creates that value with the key C1, some value, and also its type. Now, anytime you interact with this checkbox, whether you check it or uncheck it or programmatically set the value, get the value, you're always interacting here, and it's reflected on the checkbox itself. The same goes for input float. Now, one thing you'll notice is every widget has a keyword source, okay? And what this is this allows you to override what the value is, what the key is in the value system. So, for example, and by default, by the way, it uses the name of the widget. But if you actually specify it, it'll use that instead. And part of the reason you may want to do that is you may want multiple widgets to control the same value. For example, here we have an input int and a drag int3 controlling the same underlying value. Which there's other reasons you may want to do something like this, especially whenever we go to some of the things with plotters and the drawing API, where you can actually have a widget directly control something else. For example, a drag line on a plot, when you move it, it can control this value, and this value can control the drag line. But we'll get into that in a later video. One of the other things to basically keep in mind is when you go to add this, for instance, in input int, and you specify the source as common, for example, it'll look in the system, and if that value is not there yet, it'll add it. The second one will, again, check to see if it's there. If it's not, it'll add it, but if it is, it'll say, okay, that's the value I'm pointing to. So one of the important things about this is the types have to be compatible. If I was to try to link a checkbox and an input int, that wouldn't work. The size also matters. So, for example, if I were to add a drag int3 first, so let's take a step back. The first item to actually add it here sets the type for it. So in this case, if you were to actually add an input int before the drag int3, this actually wouldn't work because the value here would be just a single, let's say 1, for example, which works fine for the input int. But when you go to a drag int3, it needs 3 values to control. So this would actually not work. And when it doesn't work, it doesn't fail or anything like that. What it does is it just resorts to a common, there's actually common values here for each type that it'll just resort to that. But you won't have access to that. So what you need to do is you've got two options. You can either define the drag int3 first, in which case the value logged will look like this. And then when you go to create the input int, it'll work because it'll just control this first value while the drag int3 will control the whole value. But that is not practical in a real system. You don't want to have to say, well, you got to define your larger widget value controllers first over these. That's not it. So what you can do is actually pre-add a value beforehand, which is what add value does. That's really the only case you want to use this for, is you would want to basically go ahead and pre-add a value with 3 slots, and then the order of this doesn't matter. Input int's going to see it's already there and use it. Drag int3, same thing. So hopefully this kind of makes sense. I'll actually go ahead and show this in practice so you can kind of see what this does and see this in action. All right, so to show this in action, let's go ahead and create a window and create the widget. We'll go ahead and add a checkbox. Let's follow the diagram. We'll do that. Add input float F1. And again, we're going to use the debug tool because I'm going to show you something about this system. So if you go to run this, you'll see this. All right. So like I said, C1 is not actually containing its own value. It's in the storage system. And with the debug tool, you can actually see this right here is referring to the storage system. These are your different types that are in there. And you'll notice that the count for all of them is 1 by default. And that's because, like I said, there is a default value in there for when, rather than error out, it'll just control that default value. But what you'll notice is float values is 2, and that's because F1 is now logged in there, and bool values is 2 because this is logged there. So you can see that. Now to show the other ones controlling each other, or using a common one, let's do add input int, and we'll call it input int 1, and we'll give it source common, source com, and then we'll do a drag int 3. And I'm going to actually put this head here, and let's see. Okay, so what you'll see is that int3 got incremented, and you can see that these are controlling the same value, right? So pretty cool. But like I said, you have that issue where if you define this first and the type gets logged as an int first, this won't work. You can see that the input int increased, but nothing else increased, and that's because the drag int is now controlling the int3 common value. So if you want to be able to define them in any order you want, that's where this would come in. Add value com, and the value we're going to set is 1, 2, 3. And now you should see this working. So there you go. That is how the value system works. And there's other uses of it that we'll see, like I said, once we get to plotting and things like that. One last note is if you want to see the underlying value types of every widget, you could do show documentation. And on the first page of it, under widgets, you can see all of the different widgets and their underlying value types, if they have one. So that can kind of help you when trying to link all these together. But anyway, hope you liked the video, and if you like it, please give us a like and subscribe, and I will see you next time.